that we're going to demonstrate today, we're going to go ahead and demonstrate how to write and use a contract in Cryptofex. And the Cryptofex, or the contract that we're going to be working with is a Dutch auction. So you may not know this, but there's a lot that goes into designing auctions. The other day, I went with my wife to her parents' house, and they sort of asked the question, like, how's work going? So I'm like, I work on this blockchain thing I've already explained, and we're sort of working on this tool for writing smart contracts, and you don't know about those things, but you know about auctions, so I'll talk about auctions. And so I spent the whole dinner talking about auctions, and basically ruined the whole dinner. So maybe it's more interesting to you guys though, because being smart contract developers. So there's one traditional design of auction you're probably familiar with is one that's used in, you always see it in the movies where there's an auctioneer and they're trying to sell off an item, and the participants are just sort of shouting out their prices, and the bid is going up and up, as people are shouting out their different prices. And that auction works well for the seller, I guess, because it's sort of encouraging the price to increase. But there are a lot of disadvantages to that style of auction. One being that shills in the audience can kind of manipulate it, so you can plant someone in the audience who can sort of push up the price. And in that environment, people are maybe trying to get away with different things. They're trying to get away with the best price. And anyway, there are all sorts of disadvantages to this traditional auction design. So then you say, well, maybe we'll do a silent auction so that people don't know what other people's prices are. And there are some risks there. So maybe you want to bid really high, or you're afraid that your bid is going to be really high relative to the other participants in the auction. And so, maybe you do this bid, and you bid 10 times more than everyone else. And then all of a sudden, you way overpaid for this item, but you didn't know that because you're in a private or a silent auction. And so there's some disadvantages there. People aren't really comfortable with that. They sort of are more conservative. So different trade-offs there. Ideally, what you want in many situations is to reveal the participant's true price that they want to buy the item at. And so there's a form of auction where it's a silent auction where everyone bids the amount that they want. The person who bids the highest amount wins the auction, but they pay the price of the second highest person. And so this is the best auction design that we know of that's for revealing the participant's true price. And so the US government uses it to do things like sell off land, situations where they want the item to go to the best possible, the person who desires the item most. But the auction that we're going to be talking about has its own advantages. It's called a Dutch auction, and a Dutch auction is designed to sell an item really quickly. So the way that it works is that the auctioneer will set the bid for the auction at an absurd price, something really, really high. And then they gradually will lower the price until someone bids. So now the first person who bids wins the whole auction. So in the case of the traditional auction where everyone's sort of shouting out prices, you're sort of playing off people's competitiveness to get the item, right? This guy bid and this guy bid, and you're sort of fighting over who can get the highest bid so that you can win the item. Whereas the Dutch auction sort of plays on your fear of missing out. So as the price gets lower and lower, you can save a little bit more money, but you start to get worried that someone else is going to jump on it. And so it works really well for selling the item quickly because people, you don't want to miss out. You don't want to be the last one in. You want to be the first one in. So I'm going to turn it over to Alpheus. He's going to explain the code here. And we sort of debated about whether it'd be a good idea to actually write the code with you in here. We decided that rather than fumbling around with the keyboard, what we would do is just explain it step by step, just like here, but keep it written.
So the first thing I think I'm going to do is increase the font size.
We're also both Vim guys, so we have Vim and Emacs key bindings. Yeah.
The Vim key binding is more tested than the Emacs bindings. And they also, and while we've done a lot of work to extend them, there's still work that we need to do. But it's fairly workable at this point. And so So here's a contract for a Dutch auction written in Solidity. The first thing that in the contract is a declaration of the variables right here. And so we have an asking price and where we start that keeps track of the current price, and an auctioneer and a winner and a seller. And we also have a Boolean that indicates that it's finished, and a mapping for each participant that address keeping track of how much money they've put in for being able to participate in the auction.
Could you talk a little bit more about how that mapping works?
Pardon?
Could you talk a little bit more about how the mapping works?
So basically, it takes for every address, mapping takes it. For every address it has, it takes an integer for escrow.
Yeah, so the mappings in Solidity are sort of like a key value store. So in this case, for every address that's participating in the auction, we need to store some amount.
And so we also have two events: asking price changed and finished, that will be sent out as the auction progresses. And so the first thing we have is a constructor that takes an asking price and an auctioneer address and a seller address, and it sets the initial asking price and the auctioneer, and it also sets finished to be false. And then we have a function for lowering the price, and this function requires an asking price to be entered, and it also checks to make sure that the sender sending the message is the auctioneer.
Yeah, so as you're designing contracts, you need to think about the different roles that are participating in different functions. And so in this case, this lower asking price is a function designed for the auctioneer so that they can control what the bid is set. And so when we require that the message sender is the auctioneer, what we're saying is that this function is only usable by whoever is designated as the auctioneer. And so it's
we also require that the asking price to be the new asking price to be lower than the old one, and that they require the auction not to be finished before we set the asking price to the new one. And once we do that, we notify everyone through it by emitting an asking price changed event, and along with what the price has been changed.
If you're familiar with other programming languages, they'll often use assertions where you can assert that a case is true, and if not, then the program fails. Usually you're pretty careful with assertions because you don't want your program to crash unexpectedly, but in a smart contract, it's totally fine to do that. You want to stop out of your method if something is not right. And so you'll see that in Solidity contracts, there are a lot of these require, which works just like assert. So we're requiring that certain conditions are true in order to proceed with the method.
And so in order to participate in the contract, we have a function for a deposit function where we require the sender to be someone who's not the auctioneer, and so basically the auctioneer is excluded from being able to bid on the item, and then we require the value of money that the person registers with to be greater than 0, and that. And the money is whatever money they put in their deposit increments their escrow.
Yeah, so the escrow account is a little bit complicated to think about. So basically an Ethereum contract lives at an address, and it has a total amount of money that has been assigned to it, but it doesn't have any way of breaking up the money. And so when people deposit, if you could scroll up, Alpheus, you'll notice that this deposit function has a payable attribute at the end. And what the payable attribute indicates is that someone is allowed to send ETH to this function. And so as soon as the ETH is sent, it just goes into the contracts pool, and then it's our responsibility to keep track of who has what money. And so that's what we do with this escrow mapping that we described earlier. For every address that deposits money, we need to keep track of that money so that they are entitled to that and can interact with it, and not everyone's money becomes mixed.
Then we have a withdrawal function. That I just accidentally folded.
You can click on the, yeah.
So we have a withdrawal function that takes the amount that's currently in escrow and requires the amount to be withdrawn to be greater than 0. And when we set the escrow to 0 and we transfer the amount back to the user, and then delete that from the records of the users with escrow.
So with those deposit and withdraw functions, if you're a user of this contract, you want to ensure that your money is safe using this contract. You don't want it to send this money to the contract and it to be lost forever. So what the deposit and withdraw functions allow you to do is withdraw and deposit money at any time. You need to have money to participate in the auction, but if you deposit some money and then decide you don't want to participate, you can withdraw that at any time. And if I'm going to use this contract, that's an important property to have so that I know that my money is still in my control.
Then we have a call function for users who want to call on a particular price. And it requires the sender not to be the auctioneer and also not to be the seller. And it also requires that the escrow of the particular sender is greater than the asking price. And it requires the auction not to be finished yet. This is the one that this is the function that takes the money out of the escrow of the sender, and then declares the sender to be the winner, and then finishes the auction. And it gives the asking price to the sender, and emits a finished message to everyone who's participating in the function.
So once again, if we're thinking about the roles of the different functions of this contract, this call function is used by all the participants in the auction. So when they call the function, when they execute this call, that means that they're bidding at the current price. And so one of the things that we required is that the message sender is not the auctioneer, but it's unclear. Well, so the reasoning being that you don't want the auctioneer to participate in the auction because they're actually the ones setting the price. So if they were allowed to simultaneously set the price and bid, they could sort of give themselves an advantage. So we disabled that, but it's not actually clear that that will prevent that from happening, because on Ethereum, you can generate as many accounts as you want, and so they could always have another account that they're using that's part of the auction. And so these are just some of the things you can think about as you're writing contracts, is how do you even enforce these situations that you want to happen, and what are some of the things that can go wrong? What's the consequence here? Here it appears that we can prevent the auctioneer from participating, but maybe we really can't.
And so now that we have this contract, we could go over to over here and click on Generate Files, and then click on the Build button, and it will build the contract and let us know of any errors or warnings. And because we have clicked on Generate Files, it also produces these two files in the directory of the current file. And the first one is the binary, it's the actual code that's sent to the Ethereum block for execution, so that and so this, I think this is in hexadecimal, if I remember correctly, but basically these are all the bytecodes that represents the program. And the second one is a JSON file that's used for to be able for other people to be able to use the ABI. And so this, I I've transferred this file to Justin so that he could be able to put it on his machine and participate in the auction from a separate machine.
Yeah, so I want to give this some more context. So a smart contract is not like a regular program where you have a loop and it's going to go through sequentially through every step and you can trace the execution. It's more like a REST service or a microservice, something like that, where you have these different parts that you can call into, all these functions, and they can be called into by anyone over the internet. And so this makes testing a little bit difficult because you can't just start it up and run it on your machine start to end. You sort of need to interact with it just like you would a REST service. And so what Ethereum does is when you compile a contract, it gives you this ABI, which is a description of all the functions that are callable on the contract. And then what our tool does, what Cryptofex does, is take this ABI and generate an interface so that you can test your contract really easily. And so just like Alpheus was saying, Alpheus has sent me this ABI, and what I'm going to do on my computer is pull this up, and I'm going to add Alpheus's contract address, and then we'll be able to interact with the contract together and sort of play out a little auction. So Alpheus, what I need you to do is go ahead and deploy your contract.
I wanted to mention first that the accounts that I'm going to be that I'm going to be attached to is actually on Justin's machine, and basically he has a client, a Ganache client, which is a test server for Solidity, and this address right here, the URI is points the Cryptofex IDE to his machine so that he could get the addresses that we're going to be using. And so when we go to deploy, it goes gets the addresses from his computer.
It's actually not getting the addresses.
Yeah.
I might have to come closer. We're running a little local network, and so I'm not sure if we, or if me going to sleep did it.
Okay.
Sorry about that. 1 second.
Sorry. Okay, the addresses are there now.
Okay.
So
when we're testing these contracts, and Ethereum represents sort of an individual in the network. So in this case, what we'll do is Alpheus will be this first address in the list, and then I will be the second address. And you'll notice already that in that constructors section that it generated a little interface for this constructor at the top of the contract. If you want to scroll back up to the very top of the constructor so we can see what we're calling. Okay, so I'm actually having some technical difficulties, so I cannot connect to show you this contract, but let me just go over to the test interface there.
well, first I was going to go ahead and deploy.
Okay.
And basically, we could do that by selecting the first or one of the keys and copying it, and then paste it for the auctioneer. And we're going to skip the seller, but we could select another one to be the seller, and then choose a unit, and then start the Dutch auction by clicking on this right here.
Oh, I actually have the address right here, so we should be good to go. Okay, actually, yeah, we're connected, so we're good to go.
Okay.
So in this case, you designated the first address as the auctioneer, so that's me. And now Alpheus will go ahead and register for the different events that we talked about, such as when we're changing the price.
So we have two events to register for: the asking price, or price changed and the finished. And we'd click to notify that we want to be notified of the events, and they'll show up in the console when they're activated. And so if we click on asking price, let's see, it should tell us what the asking price is, but it's complaining that it's
That's okay.
That the address is not a contract.
Yeah, so because of technical difficulties, I guess we'll have to move on from this section. But basically, you can see that from this interface that you can call the different functions that interact with the contract. And then as I am calling functions, Alpheus will receive the events such as lowering the bid. But let's move on to some rolling things. Sorry about that.
So the first example I wanted to demonstrate for rolling is a simple hello world. And this hello world basically takes creates an STD out channel that's tied to this URI, which is a global source. But it's the purpose of doing it through this way is that it allows you to have a private, your own private section of the global STD out without it being polluted by other people who are using rolling as well.
Yeah, you've probably heard in discussions, we've been talking a lot about unforgeable names in rolling. And so what he's referring to right there is that if this channel was just a public channel that everyone could listen to, then anyone could bombard the standard out. Anyone could take the input from it. And so by using a new there, we're able to create one which is just private to ourselves.
So when we run this, it's going to take the message hello world and send it to STD out, which will then go through the URL and produce some produce the output. And so the output right here is the hello world in the brackets, and it also gives an estimated deploy cost and the storage contents that will be on the block after this is run.
Yeah, so while we need, in order to test solidity contracts, we need this test chain that we can connect to run on where we're making these sort of REST calls. With rolling, we can just run some of the contracts in the interpreter, which is what we're doing here. And then we have this command line down here, which Alpheus can use to interact these contracts to send things to other channels, to pull things from them. And so, whereas Solidity is sort of this rigid way of developing contracts where you have to build it, you have to deploy it, you got to make all these changes. With rolling, when you're working, it's very interactive. It's sort of like a Lisp-like way where you can interact these things, and so that's what Alpheus will be showing us.
And so the next example I wanted to go with is to talk about public channels. It's my understanding that public channels are being phased out of rolling, but before they're phased out, and a way to interact with contracts needs to be added, and it's my understanding that's currently a work in progress. But for now, we could create this function right here is a function that will continuously listen to messages from the channel Aleph. And so basically, the less than equal sign means that means that every time a message is sent to Aleph, or a certain kind of message is sent to Aleph, you pick it up and then you take it and you put it and you send out the square of that message. And so if we run this example, we get it doesn't do anything yet because we just entered that function into the tuple space. But now if we send a message to
yeah, before you send that message, I just want to clarify what's happening here. So what this contract is, it's listening on this channel for something that we're going to call X once we receive it, and then we're going to do some stuff with it. But there's nothing in the contract that actually sends something there, so right now it's just kind of holding, waiting for something to come in on Alpheus' channel. Yes? Is it what? No, it's not a loop. You want to talk about what it is, Alpheus?
Yeah, actually, it's more accurate to think of for as a listen for, and actually, strictly speaking, a contract is actually a syntactic sugar for a for loop. I think it's, if I remember correctly, a contract is a continuous listening loop like this one, or a listening for like this one. And so, well,
Can you say that again?
Yeah. This for is actually a multi-shot one.
Yeah, so there's two kind of fors. If you have an arrow with a single slash, then that means that you're waiting for a single message. In this case, with the equals, that means that we're waiting for any messages that come in. And so yes, one of the things about rolling is that it's very different than traditional sort of C-style programming languages where you're expecting these sort of sequential operations to happen. In rolling, we're really modeling distributed systems, which is a more accurate model of what's happening in the computer, but it doesn't behave the way that you would traditionally expect. So it takes a little bit of a handle to get, a while to get a handle on it. And so when we're thinking about how rolling works, once again, we need to always be thinking about sends and receives. So just like Alex was saying, what this contract is going to do is listen on this channel, like we said, for all messages, and then it's going to go into that body and do some stuff with it. Yep.
I have a question.
Yeah.
We'll check on the x value, see if it's multipliable by itself.
No, that's a good observation. So yes, if we sent a string to, well, let's go ahead and send a number first.
So yeah, if we send a number, it'll send it'll evaluate the number sent to Aleph, and the loop will pull it out and calculate the square of that number.
So that's the result right there. Which part?
The 99 is something the IDE parsed out of the log message.
This is actually put out by the interpreter. So the standard out channel will put out these kinds of things, and then the storage contents is all the state of what's in the interpreter right now. And so we can actually see, let's see, I'm trying to look where it is on the, you can see that this listen is sitting on the channel right here. You see this for on Aleph, so we can see that this is sitting in the tuple space, sort of waiting for things to happen, and then it's going to receive them and do some things with them. So now he's going to send a bunch of stuff in parallel.
Basically, this time I'm going to send 3 messages in parallel. And what happens when we do this is that every time we send a message, it puts it into the tuple space. And then in the tuple space, it waits for something to pull it out. So, because the tuple space is kind of, because the tuple space doesn't guarantee a particular order that it gets put in or pulled out when things are run in parallel, this is a bit undeterministic as to what the output is going to be.
And
so
just like you anticipated there, when we sent the string hello, it didn't know how to handle that, so expression didn't evaluate to an integer. That was a good catch.
So it evaluated the very first one it ended up evaluating in this case was the 16, which is the second message. And
what happened to what? Oh, with floating point, it'll work.
Actually, I'm not sure if a floating point is supported yet.
I'm pretty sure it'll work.
Let's see.
So there's different, we can try it out.
Follow-up question. Is there a way to create, let's say you want to do y equals x plus 2 and then std out of y. Is there a way to define a variable? I haven't found that in this spec.
So the way to do that would be to have a channel, a persistent listen like this, which listens on that function channel, and it will take the y's, and you said it was y squared or y? We'll say y squared. So we would listen for y's, and then we would send back y squared. And so when you sent that, you'd have to send a return channel so they could give you it back.
But the only way to assign a value to a variable is to get it from a channel.
No, but that's
I
the
think-
only way to make a sort of function like you're talking
Well,
about, where
currently,
you're going to take inputs and do things with them and send them back. There are other patterns with match and things. Alpheus, you have a comment?
Actually, I'd say that I'd have to say that is pretty much the only way to do variables right now. And if you want to maintain the value of a channel, the typical pattern would be to pull it out of the channel and then put it back in when you're done with it. And it's a little awkward to use at the moment, but there's currently plans to add a lambda calculus sublanguage, which I think is actually going to be designed to make it easier to work with variables in particular and possibly functions. I'm not. So. Yeah.
Yes. So wait, let's do an example, Alpheus, where we send to a public channel. Let's put some numbers in there that we haven't used yet. So maybe we'll call it.
Actually, I'll go to the.
Yeah, that's perfect. So we're going to send some stuff to this channel. Is a question? No, so it'll be created when the message is sent to it.
In a way that, as I understand it, basically any, yeah, you could add as many channels into the tuple space as you'd like. So.
Now, once again, these are kind of unsafe channels because we're using public channels. The right way would be to create a new so that those are unforgeable names. But this will work for. Yes, these are forgeable. Okay, so now he's evaluated that statement, and we can see that these are sitting on the tuple space right here. So we can see that not, has this list that he created and those two numbers, and they're just sort of sitting there waiting for something to happen. And so, yeah, those are like variables where they're storing this data there. And now Alpheus is going to pull off one of those values with a listen, and maybe we'll just get rid of it or something like that, or print it. What do you want to do? Okay, he's going to print it. Sure. We could send it to any other channel. Once we get that value, we could send it somewhere else. Yeah. You need one more curly on there at the end. Okay, let's see.
Oh wait, I forgot an N.
Yep, in. Good call. Okay, so now what this has done, Alpheus, do you want to explain?
So basically when we,
Could you scroll up there actually? Scroll up a little bit.
Okay.
So this is, like we said, this is a listen for a single value. And so each time he did that, it pulled off one of those values and then printed it out. We don't know which one it's going to get. It's undeterministic. But now the values are all gone. So as we, through the history, you saw that it would pull off one of the things, then it pulled off the other thing, and then it pulled off the last thing.
and if we run it a fourth time, it's now sitting in the tuple space waiting for another message to be sent into not.
Yeah, which we see here. So now let's see, where'd it go? There it is. So there's the listen sitting there because we did one extra listen, and so now we have a listen left that's unpaged with the match.
And so now it's printed out now that I've added the one, the listen ended up doing creating or printing out the hello world or hello.
Question on the at x basically, because in the tutorial we have the x not at x. So when you are using the x as a value variable, you stand out you have been using the star x times star x.
Can you say that again?
Because in the tutorial we see all the variable name on the floor is without the at. It's an x instead of at x, for example.
Uh-huh. Are you asking why there's the at there?
And they use x star x to using at. You don't have to.
Ah, yes, that's a good question. So when you do a listen, you're finding a pattern that you're expecting that you're going to pull off of the channel. And so in this case, we're expecting to receive a name. By putting the at there, we extract the process from the name. And so this is the pattern that we're expecting, and the at is just part of the pattern, and then we get the process out of the name.
No.
When you talk about, based on the tutorial, when you talk about process, you talk about something that is evaluating the expression.
Yes, yes.
And so for on this lower line, I just removed the at and put the star in front of the x. What happens is that when we remove the at, this is a name, and then we have to convert it into a process.
You can see that this sort of interactive programming works really well for rolling, and so that's what we will hope to provide with this tool here.
The IDE is available.
Yes.
Yes.
Yeah, I think we're about getting to the end, so I can answer any questions that we have. But yes, she'll post the URL, but the URL is cryptofex.io, and it's available right now. It's currently our alpha, but we really want to get your feedback as far as what things would be helpful to you. If you write for other blockchains and there are other languages that you'd like to see, we'd like to know about that. If there are other rolling features that you'd like, we have a lot of things planned, but we'd really like to build things that would be helpful for you. So does anyone have any questions about Cryptofex or about this rolling stuff that we've demoed or anything like that?
You mentioned the big plan at the beginning of the talk for the editor. Can you reveal a bit of what the big plan is?
Sure. So if you want to get the most detail, I'd recommend you read Nash's Medium article introducing Cryptofex. He sort of outlines the whole plan, but basically we don't want to just write contracts in here. We want this to be a sort of total development platform for writing smart contracts. And what that would include would be things like publishing contracts so that other people can get them and include them in their projects, and then also downloading contracts and including them. And then we've also talked about having some kind of cloud services related to compilation so that you can take advantage of these cloud services for building projects, but sort of allocate resources for those through the blockchain. Say that again? Yes, we want to do a lot of debugging stuff as well. One of the things that you can see here is it's kind of hard to read this tuple space printout right here. And so we'd really like to make a tuple space explorer so that you have a little UI and you can see every cell and the values inside of them and interact with them. Some other features for rolling that we'd like. If you could click on the deploy tab there, Alpheus. So this is sort of a local evaluation. You don't need any node here. This is just running inside your editor. But you can also interact entirely with the node from inside Cryptofex. And so if you want to eval something on a node, if you want to deploy a contract, you can do that from here as well. You just got to configure the parameters, and you can connect to your node and interact with it that way. And so, as your question pointed out, we sort of have a lot of cool Solidity features that we wanted to demo, and we sort of have a more basic rolling implementation. And the reasoning for that is that our chain is sort of a moving target where they're adding new features every single week, right? And so we sort of do our best to keep up with them, but we can only sort of do as much as the RChain project has progressed. And so there are lots of things that we are planning to do and will do as our chain completes them. But since Solidity is a more mature system, there's lots more tools that we can provide. Yeah.
One thing I always struggle with when I'm writing smart contract in Solidity is I have to reveal my code, my source code, and the only way to do that right now is an user scan.
Mm-hmm.
And it's a pain in the butt. Do you have a better solution
For
for deploying the source code along with the contract? Making it provable that this is the source code that this address is running.
So the only technical way to verify that the source code is the same on the chain is for me to have a copy of the source code and you to have a copy of the source code and us to build and compare the binaries that result from that, because the chain only stores the binary.
Correct, but our chain can store data,
That's correct.
and you could also store data somewhere else. You need the piece of software, a script that does the work for you.
Well, yes. So we definitely want to provide a service so that you can publish your smart contract and so that other people could find that and see that code. But as far as storing it itself on Ethereum, I don't think that we have any plans to do something like that.
But
Will be a smart contract that where you can publish the hash of the source code or the hash of the last commit.
Uh-huh.
Then the script that goes and fetches that source code, compiles it, compares it with the bytecode, and says, yay.
So
actually,
you can be sure. What do you
it's,
think, Alpheus?
it's my understanding that we're still trying to work out how that would work with rolling in our chain, and and we expect the Cryptofex IDE would be that we'd be adding features as those details become more clear, so that things like that could be done more easily.
Yes.
Yeah, so you might have said this before I came in, so sorry to repeat, but I was just wondering where the estimated deploy costs are coming from, because I thought this was still kind of in the process of being determined and the preparation of the chapter as well.
Yes, so that is true. It's still in the process of being determined. So basically what they're working on right now is inside our chain, they're writing code in the interpreter to assign different costs to different computations, right? So that they can account for those things like if I send a message, how much is that going to cost? And so they're still working out what those values should be and the accounting in there, but it's in progress. And so they've put it in the code, and so we're getting the output of that.
Okay, so it's just like what's currently estimated.
Yep. Okay, well, it sounds like you guys may have more questions about rolling. If you want to talk to us one-on-one afterwards, we'd be happy to show you more stuff. But I appreciate you coming to our presentation. I apologize for some of the technical difficulties, and we hope that you download and try out Cryptofex. So thank you.
Actually, I should add that we will be available in a couple of hours for answering other questions as well.
Yeah, we'll just be over in the lunchroom area, so come find us.